Hello, hello viewers. So today we are going to learn this beautiful concept in an embedded system. This is what is memory alignment and the size of the structure. So we'll start this. Welcome in Infinite Academy. So we'll start this. What is memory alignment and the size of structures? For you, I have defined some binary and hex. These are just assume these are the addresses I have given. So left hand side these are the binary and the hex value is this. I have defined one structures. There are three variables which contain three variables. One is 32-bit, one is character type, another one is 16-bit. I have assigned some values. We'll see how those values are mapped in the memory, and we'll find out what will be the uh, what like size of this structure, and if the order of those variable initialization is changed, what will the size of that structure again. So okay, we'll start this. So as you know this, you can see this, what will the byte, it contains x will be 4 bytes, right? So I will write here 4 bytes, and y will be 1 byte only because character type. And what is the data type of z is 16 bit, so it will be 2 bytes. So if you calculate, can you guess what will the size of this structure? If you are thinking the size of this structure is 7, then you are wrong. The size of the structure will not be a 7. We'll see what will the size of this. So the thumb rule to get how this variable is aligned in a memory. So first you think this is like 4 byte, right? So this will be mapped in the memory wherever this address is divisible by 4, because this is 4 bytes. So if you see where is the address, it can start from this place, it can start from this place, it can start from which place, 4 and 8 place, this, because all those numbers are divisible by 4, and it can start, see, like that it can start. And okay, so we'll fill this value. So we know this memory address are empty currently, so it this whatever the assigned value to x, it can go to this location. So x, we have the value this like 67 58 4 5 3 4. This is hexadecimal value, will map in the memory, how it will be go. So I will write for you. Okay, so I will write here. So this 61, okay, I will write with this only. Okay, so we are so there is a Endianness concept also there. So I am storing in Little Endian. Little Endian means the LSB store first. What is the LSB in X? So LSB in X is 34. So we'll keep 34. 0x34. What will the next will be? 0x45. Okay, 45. 0x, what is the value? 58. Correct. And the next, what will be the value? 0x67. If you are writing in the Big Endian, then 67 will become first, then 58, then 45, then 34. Okay, for this example, I am just taking a Little Endian. So LSB stored first. Okay, done. So okay, how that's how x will be aligned in the memory. We'll see now y. Y is a character, it is a 1 byte. So see, every address is divisible by 1, so it can go next after this. So it will go and it will fill the value. What will the value of x? 0x 8 9. Fine. See, we got those values. Now next, uh, what? Okay, z is just 2 bytes. So 2 is divisible. I will tell this. See, 0 is divisible by 2. 2 is divisible by 2. For this memory address is divisible by 2, 4, 6. Okay, any even number will be divisible by 2. So we can fill anywhere. So if you see, we can't fill on 0, 5. We have to fill from 0, 6 only. So we'll fill that value from 0, 6. Okay, So what will the value in the Lithuanian LSB store first? So what is LSB for Z variable? That is 60x. This is the LSB 12 and final 0x 43, and these bits are undefined. So the compiler, what it will happen, it padding will happen here. So padding concept comes in the picture. So if you see, what will the size of this full structure? This like 8 byte. If you see 1 2 3 4 5 6 7 8, 8 byte. And see why I was telling that 4 bytes, like in 32-bit architecture. See how the calls will happen, like this block wise calls will happen, and like CPU will take the value in this 4 bytes in 32-bit architecture. So if CPU only one call, then it will get the value of this x. The next call it can uh, get the value of, sorry, it should be here to here only. Next call it can get the value of y and z. So that's it. Okay, now what will happen if we change the order? We'll see now what will happen if we change the order. So now here in this case x, y and z, once order has been changed here. So x is what? Okay, to now in this case x is okay. Sorry, I have to change the values also. I will change. So this is z, this is x, and this is y. Okay, so in our memory next, okay, what is z is 2 byte, so we'll fill that. It is 2 byte can be filled wherever it's divisible by 2. This address is divisible by 2, this address is these previous also addresses are also divisible by 2, but those are filled, so I'm not taking that. I'm in the new memory locations, I'm filling those data. So I will fill this z here. Okay, one more thing, where this 32 can go, so it should be divisible by how many? Okay, which number is divisible? This c means 12, so this is divisible by 4. Okay, this is also divisible by 4, this is also divisible by 4, and okay, c, okay, this is also divisible by 4. So we'll fill the data accordingly, and the y can be fill any address because it's one can divide to anything. Fine. Okay, we'll fill this. So on this sign, as I told, I will fill in a Lithuanian. So LSB store first. So what is the LSB for Z? 0x10, 0x43. Okay, and the next is for x. You can't store here, so you will have to store from 0 c. Why? Because it is divisible by 4, this address. So we'll take LSB first, 34, next 45, next 58, 0x58, and finally 0x67. What we left? Okay, y is left, so y can go next. A0 x 8 9. Okay, so if you see, this will be padding this byte. This is also padding, and this block, this section also is empty, so it will fill padding here also. As I told, the CPU executes in the block wise. CPU executes in the block wise, so we need to fill those memories. We can't keep those empty. We need, so what will the padding will be applied here. Okay, now the size of those will be 12 bytes. If you change the order, same variable, we just change the order of those variables, and we got the 12 bytes. Initially it was how much? It was 8 bytes. Okay, so that's how memory alignment and the size of structure will work.